Hello, and welcome to Lesson 7-5 on solving two-step inequalities. Our objectives tonight, you're going to be able to solve two-step inequalities, and you're also going to be able to use these inequalities to solve word problems. Now, in the past, we've solved really one-step inequalities like the one shown in the warm-up. All right, there's the greater than sign, the less than or equal to, and the greater than or equal to. We've solved all those before. All right, so I'm not going to make you do it in the warm-up. But really, you solve inequalities and equations in the same manner. So at the board here, I have 2 times y minus 3 is equal to -5. Problems we learned how to solve in 7-1. All right, we solve it in the same manner. First, you want to do any addition or subtraction. So I get rid of that -3 by adding 3. I'm left with 2y is equal to -2. Divide by 2, and I get y is equal to -1. All right, we've done these. I bet you're pros at them by now. And now we have this one. Same problem, but instead of an equal sign, I have a less than sign. Well, to solve it, you're going to do the same thing. You undo any addition or subtraction. So I'm going to add 3. I'm left with 2y is less than -2, divide by 2, and would you look at that, y is less than -1. So in our answers, all that changed are the signs. All right, so here we have this one. Solve and graph 7 times g plus 11 is greater than 67. All right, we're going to do this one together as well, and then you get to do the next few on your own. Again, undo any addition or subtraction. They're adding 11 on the same side as g, so we subtract it. I'm left with 7 times g is greater than 56. All right, then I have 7 times g, so I divide by 7, and I get g is greater than 8. Okay, that's one part. However, they also say graph it, so I need to make a number line. Now, I don't need a beautiful line that takes an hour to do. Here's what I normally do. I do 8, and I do numbers right around it. So 9 and 10 that way, and 7 and 6 going that way. All right, when we're talking about these, remember, we're going to have circle. We're going to put a circle at 8. The only time you use an open circle is when it's greater than or less than. You use a closed circle if it's less than or equal to or greater than or equal to. So it's closed if it's equal to it. So here I have g is greater than 8. So it is not a closed circle. It's going to be open. And we're looking, and let's see. You can try different numbers in here. Well, I know automatically it's going to go in this direction because g is greater than 8. So it can be 9, it can be 10, and so on. Okay, your turn. We have -10 is greater than or equal to 1/2 times x minus 6. Same manner, but this time you have a fraction. So think what you have to do. How do we get rid of, or how do we solve when there's a fraction? Well, we multiply by the reciprocal. So go ahead and solve this, and when you're all done, we'll go ahead and go through it together. So pause me now. All right, let's solve this one, shall we? Well, my first step is to add 6. I'm left with -4 is greater than or equal to 1/2 times x. Well, again, you could divide by 1/2, but it's hard to divide by a fraction, so instead we multiply by the reciprocal. So we're left with x, and then let's see, times it by 2/1, make that a fraction as well, and I'm left with -8/1, or just -8. So we have -8 is greater than or equal to x. Have to tell you, I hate it when the number is before the x, so I'm going to rewrite it, x, and let's see, the point is towards the x, and the open mouth is towards -8. So I just rewrote it with x first. The main reason I do that is it's easier for me to redo, all right, or it's easier for me to graph, I should say. So if I solve this, let's see, it's going to be a closed circle, and -8 because it's at equal to, have x is less than or equal to -8. So it's going to include -8, but if we're talking about numbers less than that, it means it's going to get more negative. So our sign is going to go that way. All right, now here's a key point. So far we've been multiplying or dividing by positive numbers. But when you multiply or divide an inequality by a negative number, you have to reverse the sign. That is key. Otherwise, your problem's going to be all wrong. So for example, negative 9 is greater than negative 1/3 x plus 6. Well, we go through these same steps to solve it. First step, get rid of this 6. Oops, I can't add 6. I have to subtract it. There we go. So I have negative 15 is greater than negative 1/3 times x. To solve this, I'm going to multiply this side by a negative 3 over 1, the reciprocal, and multiply this side by a negative 3 over 1. So I'm left with x, and then, well, negative 3 times negative 15 over 1 is a positive 45. But if you take a look, I multiplied both sides by this negative 3 over 1. If the number that is with x, so in this case negative 1/3, if that number is positive, or excuse me, negative, I can tell you automatically your sign is going to have to reverse. So again, I'm going to state that all over again. If this number with x, so in this case it's a negative 1/3 x, if it is negative, like this one is, you are going to have to reverse the sign. All right? So in this case, instead of 45 being greater than it, it is now less than x. So we have 45 is less than x, or if I rewrite it, x, open mouth is facing it, is greater than 45. There we go. So again, we have this example as well. We can solve it together. All right, 6 is less than or equal to negative 2/3 r minus 6. Okay, first you add 6 to both sides. I'm left with 12 is less than or equal to negative 2/3 r. Looking at it right away, that number with the variable r here is negative, so I know my sign's going to reverse. But first, I'm going to multiply it by it. All right, the opposite of negative 2/3, or the reciprocal, I should say, is negative 3/2. Do it to both sides. And let's see. I'm left with negative 18. I'm reversing my sign. Is greater than or equal to r, because those cross out. And again, I like it with r first, so I'm going to rewrite it as r is less than or equal to negative 18. But again, in case you forget that whole idea of if the number being multiplied or divided by r is negative, your answers or your sign's going to reverse, just take a look at the problem. Again, to both sides, I multiplied a negative 3/2. Because both sides were multiplied by a negative number, my sign reverses. All right, and here we have this example. Dale has $25 to spend at a carnival. If the admission to the carnival is $4 and the rides cost $1.50 each, what is the greatest number of rides Dale can go on? Well, first we need to come up with an inequality to find that out. Well, we know he has total $25, so I know 25 is going to be on this side. So now we have to look at what can he spend money on, or what does he spend money on? Well, he needs to get into the carnival, and you have to pay $4 for that. Well, if you go into a carnival, you only pay that once. So I know that 4 is just a regular 4. Because you go in, you pay your $4, you're done. You don't pay it again an hour later or anything like that. You paid that $4 to get in. Then they say, well, you just don't go into a carnival just to walk around. Sometimes you want to ride those rides. And rides cost $1.50 each. Meaning for every single ride Dale can go on, it'll cost him $1.50. Well, we don't know how many rides Dale can go on. It really depends on his money. So this is the part where we add in the $1.50 times r, because for every single ride it costs $1.50, and this is going to be less than or equal to $25, because again he only has $25 to spend, so it can't be greater than, he can't go on greater rides than what the money he has, so it has to be less than or equal to. Then you solve, and I want you to solve it from here. So go ahead and solve this, and when you're all done, come back and check your answer. So go ahead and pause me now. All right, let's go ahead and solve this one, shall we? So we're going to go ahead and first subtract that 4 out, and I'm left with $1.50 times r is less than or equal to 21. Well, I divide by $1.50, I'm left with R, so the number of rides he can go on is less than or equal to, and if you solve that the long way, or if you use a calculator, you end up with 14. So he can go on 14 or less rides. There we go. So that was your lesson tonight. Tonight we talked about how you can solve inequalities. All right. Again, you just undo any addition, subtraction, undo multiplication or division. However, the key point of tonight's lesson is if you multiply or divide both sides by a negative number, your sign reverses. You have a good night, and I will see you in class tomorrow. Adios.